This is a Higher Truth production. Ladies and gentlemen, I have been working on a video, keep modifying it. What to do if you catch this coronavirus, how to make sure that you're the 90% that aren't permanently affected by this. And there's really no way to tell what the long-term implications of catching certain viruses are. That has to be played out over time, and the data has to be accurately collected and then analyzed. The latest report about HIV fragments being found in the coronavirus, we did the research on that. We were trying to confirm it, and I'm here to tell you that the answer to that dilemma is true. But don't go running out the door yet. Now, there have been coronavirus-based HIV mutagene, multi-gene vaccines. What they're trying to do is create an HIV vaccine that protects people from HIV. So what they do is they take some proteins from HIV virus, attach it to a coronavirus, try to create a cross reaction so your immune system reacts to the proteins on the coronavirus. It makes antibodies against those proteins so that when an HIV virus shows up in the bloodstream, your body has circulating antibodies to readily attack it. Now, and so there are patents specifically on coronaviruses with HIV proteins attached to the surface. Now, all of this controversy started with a paper by some PhD people at a company called BioRxiv. And it hadn't been peer reviewed, but it has been looked at by other people. And the paper has since been removed. And of course, China, their Academy of Sciences and all, they all looked at the HIV protein conspiracy and poo-pooed it all, every bit of it. But the thing is we were able to validate and legitimately confirm that yes, they detected HIV proteins in this specific coronavirus. And this is all based upon analysis of multiple but very short regions of proteins in the coronavirus. The paper by BioRxiv, with more than one author, claimed that the new coronavirus may have acquired those regions from HIV itself, and some other people made statements that may have looked synthetic. But this paper was written by and published by that company, BioRxiv, and the authors were R.N.J. Banerjee, a PhD postdoctoral fellow in virology at McMaster's University in Ontario, Canada. So the paper wasn't published by a Harvard anybody. It was just reviewed by a Harvard person. Some types of viruses can, in fact, swap out pieces of their genetic code with each other. That's what viruses do. That's why the rhinovirus every year is able to infect us again and again and again, because it changes its genetic appearance. It mutates. So every year the cold comes back, it's a rhinovirus, but yet it's still invasive enough to cause an infection. Many of the authors of this paper say that the specific coronavirus which is involved in this recent outbreak has 4 small chunks of sequences in its genetic code which are not found in other similar coronaviruses. And they even mention SARS and MERS. I kind of say, well, so what? Every year your coronavirus is going to mutate, and it's going to have something that's different than all the rest. Otherwise, your body would recognize it, fight it off, and we would stop getting sick every year. So, but other scientists looked at this. It wasn't peer-reviewed, but there are other people who did double-check the results. And these other scientists, what did they find? They found that, yes, there are some additions in this coronavirus originating in Wuhan that other coronaviruses don't have. What does that mean? And these sequences of pieces are also found in HIV. But I want to remind you, HIV is a retrovirus, and there's a retrovirus A associated with several autoimmune, and there's a retrovirus B. So and we didn't think one of those retroviruses were even found in humans, but yet they found the antibodies against those in people with Sjogren's disease, juvenile arthritis. But there was a myasthenia gravis and possibly lupus. So it was reported by this company and their PhD authors that they found sequences that mimic HIV. It was very short segments, which increases your chances of false positives because they're short sequences. It's easier to match things up when you don't have a whole lot of data. But when you have millions and millions and millions of base pairs, and then all of those add up, then you have a stronger link to whatever DNA you think you're replicating or mirroring. It's impossible to say this isn't synthetic, because we just looked at a patent on a vaccine that are trying to develop for HIV. They're taking coronaviruses and fitting them, for lack of a better term, with proteins from HIV. They're doing that already in a laboratory. It's being done. So to find a coronavirus near a bioweapons lab in Hunan, China, then the notion that this could be a bioweapon that leaked out accidentally or accidentally on purpose is not that far-fetched, especially when you look at the fact that they downplay it on the left hand and overreacted on the right. So this is what we have. We have a paper out of Canada. It was reviewed by other scientists and confirmed that the coronavirus coming out of China this year has 4 places, at least 4 segments of proteins that these short segments resemble HIV. What does it do to the virulence? Is it active DNA? Oh, I think it is. But could it alter the characteristics of the coronavirus? Yes, it could. It's just like gene splicing. But I have to point out that everything that we've suspected so far about this coronavirus, everything we've said has been right. We question the duration of 14 days. You can't even determine that in a respiratory virus. I mean, if somebody comes in with symptoms, how do you know it wasn't 1,000 other people they were exposed to 5 days ago? How do you determine that, oh yeah, somebody that you were exposed to that didn't even have symptoms 14 days ago? I mean, how do you come up with that kind of figure? So we questioned all of that, and everything that we questioned, people started backing off on and reeling it back in. So the reason I point that out is because we want you to understand, we want to know the truth ourselves. So we're researching it, and we're sharing our findings with you. If you don't like our findings, don't watch the channel. Don't watch the videos. But the bottom line is we want the truth. And when we find the truth, we almost feel like it's sinful and criminal to hide it from you. You know, matching segments, DNA segments, isn't that concerning, you know, but it does hint of something that's been altered. But I have to point out, the proteins in mad cow disease that destroy the brains of everybody that has mad cow disease, including the cow itself, all it is a protein, and it's a protein that's deformed, and it forms a triangle instead of a spiral or instead of a chain, and instead of links, it's triangles of proteins that insert themselves into the DNA and destroy cellular DNA. But I want to point out the exact same protein is found in yeast, and yeast doesn't cause mad cow disease. So finding similar and identical proteins here and there isn't that concerning, but it does and it should make you a little more aware, make you a little more suspicious, and it's just one more piece to this puzzle we're trying to put together for you. So until next time, we're putting out a video any day now about what to do if you catch this disease. It's a good video. It's solid. So stay tuned, will you?